All right, so this video is for Boyle's law. We're trying to figure out how to solve for what's missing in the equation that's given here. Pressure 1 times volume 1 equals pressure 2 times volume 2, right? So a problem like this, essentially I'll give you some information. A helium balloon contains 125 milliliters of gas at a pressure of 0.974 atmospheres. What volume will the gas occupy at STP? Now, when I say STP, right, we talked about that before, you automatically know what temperature you're at because it's always 0 degrees Celsius, but you also know what the pressure is. But the pressure varies. It depends on what you want. In this case, I have something that's atmospheres already, so my pressure that I'm going to think about for standard pressure is going to be 1 atmosphere. But sometimes I'll give you torr in the problem, so you should be thinking 760 torr instead. I gave you all those equivalencies right in the last part of the notes, right? So I gave you all those for a reason because then you could just use whichever value is necessary. But in this case, I want the 1 atmosphere, and I already know an original volume, an original pressure, and now I know a final pressure. I'm just solving for what volume that gas is going to occupy at that new pressure. So again, I'm using this equation up here. Sometimes it's helpful to figure out, okay, P1 is my 0.974 atmospheres. V1 is 125 milliliters. And P2 is 1 atmosphere. I just figured that out. I can use 3 sig figs with that, so I'll just write it this way. And then V2 is the thing I'm trying to solve for, right? If you write down all the things that you know, usually you can figure out which equation you're using. Obviously, in this case, we're using Boyle's law, but later on, I'm going to give you a prompt like this, and I won't tell you which equation you're using. You have to kind of figure it out. So since I know 2 pressures and I only know 1 volume, I can sub them in for those values in my equation. Essentially, that 0.974 times 125 is going to be equal to 1 times x, right? And I'm just solving for x. Now I didn't put any labels in here because I know that I don't really need them right now. It just makes it sloppy. But one thing you have to make sure of, right? I picked this value for a reason because this needs to match this, right? So when it's all said and done, my volume answer that I get has to have the same unit as the volume that I was given. Right? It doesn't actually matter what units you use. Like I said before, I might give you pressures in torr, I might give you pressures in psi, but all that matters essentially is that all units match when you're using equations like this. So as long as I know that this was milliliters to start, my answer is going to be milliliters. I just got to work that out. So I'm going to take 0.975 times 125, and I get 121.875. I don't really need to divide by 1. This really wasn't going to affect anything in this case. But usually, if this is a different value, you'd have to divide then, right? You're trying to get x all by itself. But my answer here is going to be 121.875. I need 3 sig figs, so I'd round it to 122. My label has to be milliliters. So you're just always going to know 3 things, solve for what's missing. Next example, I'll do it real quick with you. If you wanted to pause right now, you could try it yourself and see if you can figure out how to do it yourself. But this piston in an internal combustion engine compresses 0.450 liters of gas, and the final pressure is 15 times greater than the initial pressure. What is the final volume of the gas, assuming the amount of gas and temperature are constant? So again, I just write down what I know. And in this case, I was only given one thing. I wasn't given the initial pressure. I was given that initial volume that was 0.450 liters. And I wasn't really given a second pressure either. And I want to know what the final volume is. The trick to a question like this is, again, it doesn't even matter what unit that pressure has. I could call it torr, I could call it psi, I could call it atmospheres. All that matters is that P2 is 15 times bigger than P1. So I can make up numbers for this. I can go ahead and make P1 1 atmosphere. Just assume that it's that. Because then if I made P2 15 atmospheres, 15 atmospheres is 15 times greater than 1 atmosphere. So that's all I have to really do. So if I make those be my values, then I can just use the equation 1 times 0.450 is going to be equal to 15 times x, right? So I have 0.450 already. I don't really have to multiply by 1, but I have to divide by 15 to get my x value. So 0.450, use my calculator real quick, divided by 15 gives me 0.03. Now, I should be careful here. The 1 and 15 aren't supposed to affect sig figs because I made those numbers up. There are 3 sig figs in the 0.450, so I actually know with like 3 sig figs that it's 0.0300, right? This is a liter value, right? It's kind of an ugly liter value. Usually you would express that as 30 milliliters because those are the same thing, but that's how I solve for the answer here. It should make sense with a lot bigger pressure that volume got a lot smaller. It was 450 milliliters, now it's 30 milliliters. So you should always be able to think logically, right? Since pressure and volume are going to be inversely proportional, since the pressure got 15 times bigger, the volume got 15 times smaller. I just divide by 15, right? You could have done that even without the equation. If you understand that two values that are inversely proportional always change, right? If one gets bigger, the other one gets smaller by the same amount. So one's 15 times bigger, the other one's going to be 15 times smaller. I don't even need an equation for that. But I got my answer here. And that's how I'm going to do Boyle's law.